Hi everyone. Today we're going to talk about how Earth maintains balance and stability. So let's get started. So, the Earth is actually self regulating, and the Earth functions as one dynamic system made up of multiple parts that are interrelated or work together. So, there are interactions between the air, the water, land, and life, and they all work together as the parts to create the whole system of the Earth. And as they work together, they maintain balance through feedbacks and cycles, which we'll talk about in this video. So, first, what is the Earth system? Well, remember the a system is um, uh, made up of several parts that are work together to create the whole, which is the system. So, in the case of the Earth system, system is also made up of several parts that work together to create the whole system. For instance, we have the biosphere, which is all the life on Earth, the atmosphere, all the air on Earth, the hydrosphere, all the water on Earth, the geosphere, also called the lithosphere, which is all the land or physical components of related to Earth. We also have the cryosphere, which is all the ice on Earth. And between all these spheres or parts, there's a constant exchange of matter and energy, for instance, the water cycle and even the carbon cycle. And because of this, the Earth actually behaves like a single functioning organism made up of these different parts that work together. So, what are the forces that drive the Earth system? There are several types of forces. First is our physical forces that may include volcanoes, radiation from the sun, ocean currents. There are chemical forces such as the cycling of carbon and nitrogen between the different systems or parts of the earth. And there are also biological forces that humans are part of, such as photosynthesis, respiration, and decomposition. Now, Earth balances itself through what we call feedback loops, and there are two types. There are negative feedback loops and positive feedback loops. So, negative feedback loops actually help stabilize the system. As an example, let's look at carbon dioxide. Say there's more carbon dioxide in the atmosphere, which is true currently, and because of this, there is faster plant growth happening. And if there's faster plant growth happening, then those plants will use more carbon dioxide, which will reduce the carbon dioxide level in the atmosphere. And if there's less carbon dioxide in the atmosphere, then this will slow the plant growth. And if there's slower plant growth, then more carbon dioxide will end up in the atmosphere, and that will increase the plant growth. And this creates this loop that constantly stabilizes the system, brings the Earth system back to stability, not letting the carbon dioxide go up too high or not letting the plant growth go up too much. But then there's also another type of feedback loop called a positive feedback loop, which actually amplifies a change that happens or worsens a condition. For example, right now we're dealing with global warming, and because of that, snow and ice sheets are melting. And if this happens, then darker surfaces on Earth are being revealed because ice and snow are very light colored, they're white. So, if more darker surfaces on Earth are revealed, then the albedo is reduced, meaning albedo is how much light is being reflected from the Earth's surface. If you have more darker surfaces, then more light is actually being absorbed than reflected. And if more light is being absorbed, then this increases the absorption of how much sunlight is being absorbed by the Earth's surface. And this will increase the temperature, which will cause more snow and ice to melt. And this creates this loop that amplifies the initial change, worsens it. So these are the two types of feedback loops that we currently see in the Earth's surface or in the Earth's system. Now, even though the Earth knows how to stabilize itself, it does have certain thresholds and tipping points. Systems can shift suddenly past a critical limit. So currently, through our human activities, we're causing many changes to the Earth's surface, and the Earth does know how to stabilize itself, but only to a certain point. If we pass that point, what we call a tipping point, then these changes are often irreversible. The Earth cannot always come back to stability, and this can cause permanent change. And Certain things or certain tipping points that we're currently approaching are the collapse of forests, the breaking up of ice sheets, the interruption of the Atlantic thermohaline circulation, which is disrupting the ocean currents, which may disrupt the climate in different regions, as so on and so on. Remember, the Earth system is made up of so many parts that are all interconnected. So one change can cause multiple changes to other parts of the Earth system, and which we will talk about more in a future video. So the thing about Earth is the Earth has been stable for a long time because it is able to use these feedback loops to come back to stability. And because of this, the Earth has remained habitable for billions and billions of years, despite major disruptions such as mass extinctions or glacial and interglacial cycles. And even the Earth is regulated by natural cycles, such as the carbon silicate cycle, in which carbon dioxide is constantly being recycled in the Earth. So that hasn't been and reaching a threshold hasn't been an issue for billions of years because of Earth's natural cycles. But then why does understanding this matter? Well, understanding the Earth's history and how we're impacting the Earth currently and how all these systems are interconnected reveals the limits of Earth's natural recovery. Just because the Earth was able to recover for billions and billions of years through its natural changes doesn't mean that it can um, reach a threshold or a tipping point where stability it cannot be reached or change is irreversible. And because this is so important, understanding Earth's history and how we impact these systems and how these systems are interconnected can help us predict future changes and inform us how our impacts as humans on Earth can have massive changes through different parts or components of the Earth system and how we can manage these changes. So, in the next video, we're going to talk about patterns in Earth's climate. We'll explore how Earth's climate cycles have happened in the past and how there have been abrupt shifts in the Earth's climate in the past as well. We're going to talk about ice ages, interglacial stages, and also surprise shifts in the Earth's climate. And we're also going to talk about what past patterns in the Earth's climate reveal about Earth's stability. That's it. Thank you.